Alright, so this video is we are going to be using similar polygons to solve for a missing side. So before we were using polygons, or we were given polygons, triangles is what we did before, but polygons, and we're identifying, are they similar? Now we're going to use the fact that they're telling us that they're similar to then solve for a problem or solve for one of the missing side lengths. So once they tell us that ABCD is similar to EFGD, we know that all the corresponding angles are the same, and we know all the corresponding ratios are proportional. So they want us to solve for x. What is the value of x? So first thing you should do is say, well, where does x represent? So x is FG. So when you do this, it doesn't matter how you do the first one. You can create any kind of ratio you want. Since they do have it written as ABCD is similar to EFGD, I'm just going to stay consistent, and I'm going to write FG in our denominator because that's how it would be represented if we were to solve this otherwise. And then I look and say, well, where does FG correspond to? And FG was our two middle letters, so it corresponds to BC. And BC, they told us, is 7.5. So we'll just write BC. All right, now from here, what we need to do next is we need to be strategic in what we're picking, because I don't want to pick and talk about AB corresponding with EF because they give me 5 and Y, and I don't know what Y is, so I can't solve for that. The only other sides that they give me that correspond and that I know I can use because they give me the information is they tell me that AD, in this case, AD is equal to 9, and AD corresponds to ED, which they tell me is 6. So I have to use those two. And since I put the polygon ABCD in the numerator last time, I need to put the polygon ABCD in the numerator this time. So it needs to be AD over ED. So this is what matters. You must be consistent in how you set up your proportion. Right? You could flip these, you can make the reciprocals, you can do other things with these as well, but it's all about consistency. Now I'm going to substitute what I know. So BC is equal to 7.5. FG is the x that we don't know. AD is equal to 9. And ED is equal to 6. All right, now remember we went through this in our last video. We can cross multiply to solve for this. So 7.5 times 6 is equal to 9 times x. Well, 7.5 times 6 will give me 42, 3. So 45 is then equal to 9x. And then we divide each side by 9. And x is equal to 5. All right, so that would be letter B, x is equal to 5. So that was using a given similarity statement to then solve for one of the missing sides. We could also, if we really wanted to now, we could solve for y. I know it doesn't ask us to, but we could if we were asked to. All right, now the next couple problems that we're going to do, they're not similar polygons, but you'll see we create and we set up proportions to solve. And this is going to be using what's called scale drawings or maps. All right, so for this one, in a scale drawing, all lengths are proportional to their corresponding actual length. So if I tell you a car is really 30 feet long and its width in a scale model is 3 feet long, then we use that same proportion to solve for the other missing parts. All right, the scale is a ratio that compares the length in the scale drawing to the actual length. All right, so we create these, and we're going to create these proportions. Now remember, it's all about consistency. So the lengths used in the scale can be different units. For example, a scale can be written as 1 centimeter to 50 kilometers, 1 inch to 100 miles, or 1 inch to 10 feet. You don't need to convert these units when you're doing a scale drawing. There are times where you do have to convert. This isn't one of them. When you're doing a scale drawing, when you solve for the missing unit, it will automatically put it in the units that you need. All right, so when we go through some examples, I'll show you the difference in class about when you need to do conversions and when you can just solve for the missing variable. All right, so let's use this and solve for an example. So the diagram shows a scale drawing. So they tell us it's a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the two towers is the main span. All right, so that's the difference, is the main span. What is the actual length of the main span? Now, they give us this information that 1 centimeter is equal to 200 meters. And then I measured this distance, and this distance was 6.4 centimeters. So I want to find out what is the actual distance in real life. So we need to create a proportion, and it doesn't matter how you do this to begin with, but you need to be consistent. So I'm going to write our scales that were given here. So I know 1 centimeter is proportional to 200 meters. All right, so there's our scale. And then the scale drawing, I was told, is 6.4 centimeters. So since my scale was in my numerator last time, this is what I'm talking about where it is important, you need to be consistent. Our scale needs to go in our numerator this time. And we want to now find the actual length. Well, we don't know what the actual length is. That's what we're solving for, so we can denote it by any variable you want. Let's just say x. All right, now we could keep the units if we want, but let's just rewrite it without the units. So 1 over 200 is equal to 6.4 over x. And then we will use our cross multiply. Sorry about that. We will use our cross multiply. So then it becomes 200 times 6.4 is equal to 1 times x. So x is equal to 1,280, and then just make sure you add your units of meters at the end. All right, so the actual, since this is a scale drawing, the actual distance between the main span is 1,280 meters. All right, and that is it for this video and it for this section.